It is. Right. On you go
Good,
then. Leave you with
good.
it.
Okay. Well, thanks for you guys for not going to the pub tonight as an option. Yeah, I work for a company called Free Market. I always advertise the company I work for at the start, if only because they allow me to spend time doing talks and when user groups come back in person, they allow me time off to go to them and things like that. So it's very good of them. What's Little Fluffy Clouds about? If you haven't read the abstract, it's kind of an overview. Well, we're going to be talking about platform as a service, but I'm going to give a quick overview of strategies for cloud deployment, lift and shift, the old virtual machines with network support that you kind of get. Platform as a service, some virtual machines, but lots of cloud services, 100% microservices. So it's all the new shiny containers, Kubernetes, which is even not new and shiny compared to serverless, the oxymoron if ever there was one. But we're going to drill into the PaaS services with an Azure focus. And it's partly because when I joined Free Market, they are completely Azure based. They are on using lots of PaaS services. And I kind of got to see the advantages and disadvantages quite quickly. We have the ease of use, the point and click demo, the kind of thing that Microsoft love at conferences where you do about 4 clicks and it makes everything work. AWS, to be honest, do point and click demos that are like click it about 5 times and it works. But those guys understand how all the permissions work. And that's why it works. Whereas everyone who tries to do it themselves tends to get tied up in permissions. It was my experience with AWS services. And the other thing I want to cover is the last 2% you can't configure, or 1%, or whatever percentage it is that annoys you. And the workarounds we used, you know, when we hit a thing we couldn't change, because you have to get the swear box out, which in this case, because I'm a northerner who grew up near Wigan, it's Uncle Joe's Mintballs, which famously keep you all aglow. And in a song by Mike Harding, you give them to your granny and you watch the bugger go. So Little Fluffy Clouds, someone's already referenced it. It's the orb. I was so into the orb at uni, I painted t-shirts, and that's me having hand painted a t-shirt with that logo on. And for those who are into the latest thing of music that woofles and doesn't play properly and isn't a CD, you can even still get it on cassette on eBay, which is quite impressive. And Little Fluffy Clouds was the breakthrough thing, even though a huge ever-growing pulsating brain that rules from the center of the ultra world was when I first heard the orb on John Peel, a 30-minute session or something. But Little Fluffy Clouds had the Harmonica Man by Ennio Morricone at the start of it, as well as sampling Ricky Lee Jones, which one reason I'm not playing the Little Fluffy Clouds as part of this presentation is copyright regs. And they got sued by Ricky Lee Jones for the audio commentary in it, and they had to pay $5,000 for permission for having not asked permission, which is quite interesting. Who am I? Well, I've worked as an application architect at Huddle. I've done loads of startups, but the last 10 years has been at Huddle and Free Market. So in Huddle, I worked with people like Ian Cooper, Toby Henderson, and we were busy moving a monolith to microservices. By the end, we were doing things like moving a US data center completely into AWS, lift and shift, all virtual machines. And if you had a 2-node enterprise SQL Server enterprise cluster, you ended up with 2 VMs in AWS and a storage array configured in AWS to act like the SAN that you would have had in SQL Server days. So it was pretty much a lift and shift. Whereas when I kind of came over to Free Market, as I said, Azure, they'd been on Azure from the very start. They'd even been in the, what's the program called that you got loads of free software from? Damn. BizSpark. So they'd even had the BizSpark license at one point and got free credits and loads of software. And they are PaaS, so they were just using everything that kind of is easy to use in Azure, mainly because, and one of the key bits about that is no tech ops people, no sysadmins. It's completely devs. I hate to use the word DevOps. And to give you a feeling about how much is in the cloud at Free Market, 4 months into being there, we went into lockdown and everyone left the office. And the only thing we had in that office was a scanner combined with a printer in the corner of the office. Everything else was portable, not one desktop, and everything we used was in the cloud. So it was very easy to kind of head out and work from home. So in lockdown 1, I tidied up the garden, which took about 4 weeks to go from complete wilderness to something else, really nice raised beds and stuff like that. I obviously finished that. We all got let out, we could do things, and then lockdown 2 hit, which was fine because by then builders were knocking the top of my house off and building on top of it, which meant everyone had to live with a hell of a lot of noise. And a headset like this with a microphone that doesn't pick up the fact that someone's removing the ceiling above your head, it was quite handy at that point. I also had to get a Land Rover off my drive as part of that. That Land Rover hadn't moved for 18 years. Only cost about £2,000 to get moving, and is now one of the best things I did was keep that, because it will be tax-free in a year's time and capable of going to the low emission zone in London, because it's a historical car. And how historical is it? When that was built, C++ and Objective-C were just being launched in 1983. And yeah, I go cycling a bit as well. So let's go through an overview of cloud strategies. So lift and shift. That's what we did at Huddle. We took an existing data center and shunted it into the cloud. Lots of virtual machines, including like Windows Server machines that were running web servers and having to have multiple of them and then putting a load balancer in front. Database was SQL Enterprise Cluster. We even moved Redis in there and had Elastic as well. You tend to not get an optimization for the cloud. So you're lacking the kind of resiliency that you can get by using some cloud services. There are some things in there like Azure has a regional recovery that can recreate your VMs in a different region and things like that, but it's still not the kind of flicky switch. It just fails over easily. You've also got to provision your virtual machines. So CPUs, memory, disk space, you've got to think about all that. You've got to work out how much storage you're going to need for your SQL. You're going to work out how much, if you're still using an old-fashioned kind of backup software, you'll end up working out how much storage you need for all your backups and things like that. And you're probably still handling licensing, patching, system management, all the stuff. But you get to completely control it. All right, you want more than one network adapter, you can have it. Server level configuration, you control the updates, so there's no surprise update coming from Amazon or Azure or Microsoft that's going to suddenly cause your app to stop working because they've updated your app service to the latest version of Windows or .NET or put a patch on, or even upgraded the kind of network. Although even with lift and shift, you could be caught by network upgrades that are kind of slightly incompatible. So from large clouds, you kind of get to tiny clouds, which is microservice, Docker, and Kubernetes. So this is the kind of full microservice solution. This is the dream of container-based deployments, and you can use trusted container-based images so that you can happily get the latest updates because you just rebuild your container with the latest image. And probably have Kubernetes or similar orchestration to manage the system, you know, because it's quite hard to manage it yourself. It's really impossible to manage yourself. And even with Kubernetes, it can become complex. So there's even layers and above Kubernetes that help try and make it easier to manage. It can be harder to manage local development environment, but saying that, we're starting to use Docker at Free Market to do local dev. And we're doing that because we're going down a microservice route, but we're not going to deploy in containers. We're still going to employ in app services. So, but the Docker for local development actually makes our life easier. But things that would be scary to do is if you were doing a Redis cluster in Docker, you have to start understanding all the networking for Docker. So it's got port mapping. You've got to get all the port mapping correctly. The Redis cluster has to realize it's being run in a certain way. And you can get with SSL certificates, you can end up having to sort out those, and with all the IP addresses flying around in Docker and things like that. So it can make life a bit harder. But what if you went to nano clouds? What if you did serverless? Yeah, it's still on a server, but so you only pay for what you use. Scaling's handled automatically. Someone else is provisioning all the runtime engines, so they're patching whatever. They just give it, you're on the next runtime engine that's probably completely patched. You get stateless processing, so you've got no local storage, which makes it really reliable in that it's very, if you go to that function every time, you're going to get the same result because there's no local storage polluting the kind of processing. So these are things like AWS Lambda, Google App Engine, and Azure Functions. The only tricky bit with it is once you really, really need to use it a lot, you probably could save money by not using serverless and actually starting to provision services or virtual machines anyway. So you have to be awfully careful about how you use them. You certainly don't want to accidentally have a Azure function that calls an Azure function that then calls back to the original Azure function that then calls that Azure function and just loops around forever, causing your bill to go stratospheric and fill your credit card statement. Which only happens occasionally, but it could be you, kind of national lottery, but for Azure functions. So that's serverless. There are other terms where serverless is now being, I think, slightly abused. There is a SQL Azure serverless, which is kind of a bit weird. In that it's a database server that might only come on if it starts getting talked to, but it isn't stateless because it must have the storage, and it can scale a bit, and you can fiddle with the figures. But the more I looked at that, the less it looked like it was a sensible thing to use, unless you have really, really bursty usage that needs to be rapidly scaled. So I'm going to talk about little fluffy clouds, which is platform as a service. It's not serverless, but it's definitely less server, is how I describe it. So you're not expecting dedicated hardware. You haven't got dedicated hardware. Failures may be transparent. So if something dies, you may not ever find out about it. But however, you may, and it can go wrong. So you have to be ready for things like, not quite chaos monkey, but you need to know that you might lose a bit of networking, you might lose a bit of CPU. And you've got no operating system to worry about. So obviously there is an OS, and you can see that later when we fiddle with an app service, but you're not really trying to think about the operating system. Yes, you select Windows or Linux, but it's abstracted away. So when I have an app service, I say I want a Windows box, I'm going to target this version of .NET, or I want a Linux box and it's going to target this version of .NET, or it's got this version of Python on, and that kind of thing. So you're relying on someone else to kind of do the work. And scaling may be managed automatically, and only may, not all the time. So let's focus on those little fluffy clouds. So I'm going to start with one of what I always felt was the hardest bit as someone who did technical support or on every fifth week at Huddle. So I had the pager, I was on duty. Every now and then we needed to patch our services at Rackspace. And when you patch a service at Rackspace, the hardest bit of that is you have to patch the SQL servers, and you have to do that in the right order, and you have to move certain services from one SQL instance to another in a cluster, reboot that one that you've just taken out effectively, patch it, reboot it, bring it back in, move all the services the other way, patch the other one, reboot. That took about an hour of your life, and it did it at 7 a.m. on a Sunday morning, once a month kind of thing. So it's a really painful thing to do. And other things about SQL were tricky as well. So one of the nicest things was coming to SQL Azure and having a team go, well, we can just restore the database to any point in the last 35 days. Not a problem. Point in time recovery, which switched on with the full period on the live database. It's a lot shorter on QA. And that genuinely means I can restore our system to any state it was. And it must be using the transaction logs and backing them up in order to do this. And also long-term retention backups. So wanted to do long-term backups and make sure we were covered on that. Looking at the make it more kind of reliable and more understandable how it was done. So you can switch that on. We now back up every 5 weeks or every week for 5 weeks. Then we at that point it goes to every month for 13 months, and then it goes for every year for 7 years. So you can restore anything back for a long time. Okay, so that's cool because it puts it in as your blob storage. So one of the things that we always had an issue with at Hurdle was when will we run out of backup space for databases? You won't run out of backup space, and it's not expensive either. And only the other day we were talking about when we move to Azure Service Bus for messaging, and we need an audit trail, but we want to clean the audit trail out, but it'd be really nice to have audit trails. So how are we going to archive the audit trails out of our databases? And I said, you're not going to archive them. They'll be in the long-term backups. If you really need to see what is in our audit trail from 1 year ago, for that 2 months or 3 months or whatever, we can just pull a backup out of storage. So we can use long-term backups in order to create an audit trail that's easy to recover and bring into a tool. And the other thing that came with it is ever since something like SQL Server 2005, there was this whiff of read-only endpoints, and you could have one write server and loads of read-only endpoints. And it was really a dream of an architect. I go, we can have people hitting the read-only endpoint, and then it'll scale better because we can just have one database that gets written to. It's really easy with Azure to set up these read-only endpoints. It's much easier to handle, and the failover groups are really much more simple to use as well. So the fear and trepidation that you had with originally, I used SQL Server database mirroring, and we had to have 3 machines with a witness and 2 main servers. I've done enterprise clusters where you have to move it between them. And even with enterprise clustering, you only got the benefit of 1 server at any time, giving you the actual data. You never got to load it across multiple servers. So failover groups makes life a lot easier, and read-only endpoints, and a built-in firewall. It was probably there, but I didn't really pay attention because you had to configure it with DDL in SQL. But happily doing the security with virtual networks, blocking access, or individual client IP addresses. So you can really start restricting it, and you don't have that situation of the database being open to the whole of the internet. So, whoops. And Active Directory and local logins. So this is a bit of a sweary thing. One of the things that if anyone's used to SQL Server, they would love to have a system admin login. If they're really smart and they're tightening up their security, each dev would probably have their own login with kind of read-only use. And then they'd have a system admin login they used as a backup. But Azure, you can only have 1 local user who's a system admin, and only 1 Active Directory user that's a sysadmin. So you can only have 2 sysadmins. And the other thing was, I was sysadmin with Active Directory on the database. Someone else needed to do stuff. And specifically what they needed to do was add more Active Directory users into SQL databases. And the only person who can do that is the sysadmin who is logged in with Active Directory. And so he removed me, put him in, and then I found I couldn't access the database at all because it removes me entirely from that database. So some of the things like that, because you're on a shared system, and they are trying to limit how many system administrators are on there for understandable reasons, because you are effectively multi-tenanting on that server. That's a bit of a bugger, and that didn't make me happy at that point. So talking about failover groups, whoops, there's me and my rubbish animations. So this uses the geo-replication, separate read-write and read-only endpoints. There's a public DNS inside Azure. That's how it does the names for the server connection. So you get apps, different names to be able to talk to your databases. Automated, and I say automated with a pinch of salt because it will not flip your database over unless it's been unavailable for an hour, which is hardly the most automated thing you might think. There is the argument that if it thought it needed to flip and it flipped, and then 5 minutes later it decided it should flip back the other way, and then 5 minutes later back the other way, you get very annoyed as well. So they've gone for a very safe period, which is now, or manual failover, which is what we will always consider how we will handle it. And you can have multiple failover groups. So if you want to have different groups of databases in a different failover set, you can actually test it really nicely. So you can test failing over, making sure everything's configured correctly on a safe database rather than the production failover group that you would like to use. And databases must be of a similar plan. So this, we had only a couple of databases in our second data center in West Europe, free market, and the rest of them were in North Europe in Dublin. And they were all on an elastic plan where you share all your database CPU and memory between all your databases. And then if one database is busy, the chances are the others aren't, so you kind of get better performance across all of your databases. What it turns out was, and I pointed this out very soon after I looked at it, was if your QA database is on the same elastic plan as your production database, if someone does a load test on the QA database, you are affecting your production users, which is a really bad idea at many levels. So we had to take everything off the elastic plan and put them onto the standard plans. So at this point, I'm going to take you to how you do a failover group in the portal. So we are now in the Azure portal. Hope everyone can see that. Thumbs up from Joel. Yeah. So, and we have two servers I created this morning. So I have a resource group that all the .NET NOTS stuff is in, and we have a NOTS EU North. North.
Sorry to interrupt. Could you zoom in a bit on it?
I can, yeah. How's that? At some point, the portal is very hard to use without, because I've never thought it was going to be that big. Is that okay?
Yeah, thank you. It's not better.
Not a problem. So we have EU North, which is in Dublin, and EU West, which is Amsterdam. I still cannot get my head around that Ireland is in the north, not in the west of Europe. But if you actually look at a globe, it's completely correct. It just makes no sense with the Mercator projection. So if we go into EU North, we can have a look at that. And we can see that there is a server name. It's not EU North.database.windows.net. No point trying to go to it because the firewall will stop you. It will probably just come up with a message if you try to go to that, telling you what IP address you'd have to add to the firewall. And there is one single database that I have bothered to put on this server, replicated database. And if I go down the list to failover groups, I've created one failover group called NOTS failover group. I am very unimaginative in my naming, as you can tell. And what you can see here is a designer thought it was a great idea to have a map of the globe when virtually everyone who is going to do this are going to have them virtually next to each other on the map, and it doesn't zoom in. Not only that, they don't put them where the place is. I swear Dublin is here and Amsterdam is here. So someone's got a bit of a registration issue of where exactly they put the little blobs. But this tells me that Nottingham EU West in West Europe is currently my primary, and Nottingham EU North, which is Dublin, is our secondary. And the other thing it tells me is if I want to write to this database, I should go to notsfailovergroup.database.windows.net. And if I want to get to the read-only version, it's notsfailovergroup.secondary.database.windows.net. So these are my new connection strings that I need, or new server names that will go in my SQL connection string. I have databases over here, and I can look at the databases within this group, and the databases within this group are replicated database, and I could have more than one in here, and they would be failed over together as a set. And you can see it's online in West Europe and it's readable in North Europe. Here's where I'm going to prove that this is true. So now I can't make it bigger because it's SQL Server Management Studio and it's tiny text, and I can only apologize for that. It's virtually impossible. I can make this bit bigger, but I can't make the results bigger, if I remember rightly. So what I've got over here is, I will just do a zoom now, see if I can do the zoom on that. That zoom. Whoa. So I'm connected to the NOTS failover group database connection here. And when I run that, I can see that in this boring table with one column, I have item 1 to 9. And I have put in hard-coded the name of the server so that we know which one we're in, because I forget. So if we go to EU, oh, it says UK West, but it's not. It's EU West. I'll just save that. Oops. Because I wanted to save at least 50p by putting it in the EU instead of the UK. Because UK resources in Azure cost slightly more than EU resources in Azure, because apparently the happy resources that can wave little Union Jacks, and that costs an extra £1 a month for a SQL Server. So to give you a feel, by the way, these two SQL servers at the lowest level, but still capable of doing a regional failover, will cost me, or would cost me, £7 a month for both of them to have a 2 GB database with a pretty low CPU level. But you've got to be quite impressed at £7 a month for 2 SQL Server 2 gig databases that are going to fail over on a region is quite impressive. And so EU North, edit it. So here we are, EU North, and that's our read-only one. So how can I tell that this is really a read-only one? I will try and delete some data. So I'm about to try and delete from this table. If I'm right, I failed because it's read-only. Yay! What a result. This is so impressive. Whereas if I go to the other one and go the EU West, which is our online database, it's the primary, I can remove item 3. The moment I go to EU North and just select the data, item 3 has disappeared. And that's it. So how fast does it do that kind of thing? So I'm just going to get ready to fail over a database. Just need to take the down 1 in order to be able to see the button. Oops. Right. So we are going to run a SQL script that all it does is tell me which server I'm on and waits 5 seconds. I go fail over, I say yes. You will see this keep ticking over saying it's on EU West. And then at some point, it will have a network connection failure. There we are, network connection failure. So it was on EU West, managed 4 times. Run it again. And hope is that. So it's reconnecting. And there it is. It's now in North. So you may go, yeah, right. But that was the tiniest little database in the world. And it is. But for free market FX, we have a much bigger database. That database still fails over within the kind of 10 to 20 seconds period. And the reason it can do that is because we're talking about a database that is replicated between the 2 nodes. So Amsterdam and Dublin are no more than a second or so out of date. So in order to be able to close down connections, make it live, to be honest, the entire time that it takes to do this, I think is probably down to how fast can they update the DNS records and update their DNS infrastructure rather than how fast can they make SQL switch. So that's a demo of failover. So the first time we did that, we booked an hour of time on a Saturday to make sure it was going to work with production, mainly because we weren't sure that all our connection strings had been altered in all the app configs and all the settings. And we found, when we did it with QA, we found 2 places we'd missed. And then when we did it in live, it worked. 1 minute to switch over. We tested it for 5 minutes. We flicked it back. And then 10 minutes into an hour of registered possible downtime, we finished. So it was well impressive. So the other thing that is the core of free market is we use Azure App Services. So App Services is the way of running a web app and some background services as well. We do it by running end service plus sagas, which are time jobs in the background. And also there's a few hang fire jobs, which was the old way of running background services in app services. This is the point where you can't do the configuration you'd do if you had a VM. We can't run Windows services in the background, so we have to do something different. Scaling instances is easy, but it's a web metaphor. It's meant to scale out. It's meant to be load balanced with more and more units, not scale up. In fact, there's only a handful of kind of scale up kind of sliders in Azure to get more powerful machine. So your background services could become a problem. So what you're really trying to do now as an architecture, is one of the tweaks you have to do, is try and make services less dependent that they have to run in as a single instance. So try and make them competing consumers. If there's anything that can be done to make them process stuff at the same time, you should do, because that allows you to scale out, not up. And if you have something that can only do that kind of single thing, it has to process things in order, or there's a connection through a third party that can only be opened once, then you have a leader follower pattern where the services are running on every app service, but one of them is always in the lead. And if it fails, it transparently hands over to the followers. But we also get slots. So app services have slots. So you have a staging slot and a production slot. They have different configs if you want to have different configs. So when you do a release, you put everything into a staging slot, test it on a URI that isn't your standard URI, make sure everything's okay, press the button, and in about 1 minute's time, it has swapped the staging to production and production to staging. And you've got a full flip release. If it all goes horribly wrong because something didn't go right, you press the button back and it can take it all the way back. This is so much easier than any virtual machine-based system I'd ever used previously. And you can use it for A/B testing. So you can use query strings or headers in order to make sure that certain users go to a certain version of your software as well. And the backups were even easier to configure, I think, than SQL, to be honest. Again, they go to a kind of storage, kind of Azure storage item, which is like S3 if you're in AWS. And I think we're currently paying something like 20-30p a month for our app service backups, because we don't store the database with them and they haven't got any massive logs or anything like that. The interesting bit is it is still a virtual environment with a command line, which is always an interesting thing to see. And as an example, so I'll make it bigger again there, now that we've got it on screen. So if I go to Knott's app service, currently it's the free one that only gives you 60 minutes a day, so it's not started. But it would be at that web address if it was running. But the weird bit is, even though it's not running as a web service, it is somehow still running, because if I go to my development tools area, I can actually go to the console. Not only can I go to the console, but I can now look at what's in my root directory. And this is where, if I go hosting start.html, you get the default file that is put in an app service if you just say, give me a new app service. Key bit, in the middle, it says your app service is up and running when you press start on your app service. So you have a command line. And when I say you have a command line, and this is why you kind of get to that, this really is still a real thing. And there you are. I think yes, there's MySQL on your app service. And it really is in there. There you are. Complete with all the exes it uses. So, and then there's stuff like Python lying around, Python 3.7, Python 3.4, things like that. So it is a real machine. And then one of the other things they've got is the advanced tools, which if you ever see, is you can actually look at called Kudu. You can do things like do memory dumps. You can look at all the processes that are running on your box and actually go in and see how much memory they're using and even kill them or do a memory dump off your processes. So even though you genuinely don't have your own box, you do have a huge amount of control that is for debugging and development. I noticed this NT version as well, and that means it's running server 2016 is what that means, not 2020 yet. There's 4 processes in this box. There's the real machine name that that is kind of used inside of your, and I load all the settings and all the environment variables are there. So the lesson here is it's still a virtual environment, even if someone else is providing it. Now, clearly, I wouldn't rely on the machine name that's in there because it will change depending on what you're doing. But with that, you can actually go in and examine all the nodes on your network. And sometimes we have had processes hang and jam, and you can kill the process off without having to restart the entire box. So that kind of thing is available, which is really pleasant. Other things about app services, single inbound IP, but they don't have a single outbound IP. When I was writing this, we were having to hand a few IP addresses out to third parties who wanted to know that the traffic's coming from us, so they want to whitelist our IPs. It all looks good when you look at the first page in the app service because it says, here's your IP addresses, but then there's the line below that says there's an additional set of IP addresses that may or may not be used at any point. That's a lot of IP addresses to give someone. I mean, a hell of a lot. So that was a bit of a swear box moment. The workaround was to use a classic web worker as a reverse proxy. That's what we had when I arrived. But fortunately, in November, they actually allow you to use a NAT gateway, which is something they only previously allowed virtual machines to use. And as long as you've got a new app service plan and you put it on a virtual network to your NAT gateway, you can lock it to a single outbound IP address. And this is really useful for third-party services who will insist you only come through one single IP address. And I can see their point of view, they're banks, right? So we're a financial institution, they're banks. The things we do, even with a client secret and the certificates, are move millions of pounds around. They want to know it's really us. This is not an unreasonable expectation. So, firewalls and VPNs, I mentioned virtual networking. So that's one of the things and that you can do with that NAT gateway. Equally, virtual networks can have a private endpoint to a SQL Azure server as well. So you can actually make sure that either an IP whitelist could say have the IP address that BT have happened to give me today and may or may not give me in the future. But also if you have a VPN client, you can use that to give a fixed IP address. Ideally, I would not tick the allow Azure services box if you care about security. This is a box that you can tick that says everything on Azure in a certain range probably can now talk to your SQL server, so you better be really good with your password and user security. I much prefer the idea of a firewall with known endpoints on it. The other thing we had to configure, another sweary thing, was we wanted the developers to be able to connect to the SQL securely. They were all entering their own IP addresses into the firewall. They never cleaned them up. And I implemented a VPN gateway, did a private endpoint for Azure, and other services, so you can actually use it to control access to other services. And then the SQL firewall allowed people coming into that VPN gateway to talk to our servers, but it became harder to use Azure SQL failover groups. And that's why eventually we gave up and we went, actually, the thing we need is an external VPN service that gives us a fixed IP address that only is for us. And that's now what we're using. So everyone goes in via a VPN and they get a fixed IP, and that IP is why they can talk to SQL Server. And that suits better the use for finance, compliance, plus developers. Because with Azure VPN gateway, everyone has to be an Active Directory user in your Azure Active Directory. So you now have another level of user management that you probably didn't want to get into. Whereas an external VPN service makes life a lot easier. One of the things we had is we were starting to split up our app services so that they ran on different different app services, but we wanted to route the traffic to them. So an API where we were doing a new thing, we wanted to separate it out so we could scale better. So instead of everything being in monolith, we'd have, you know, a kind of not a microservice, because although the API was on that box, it still hit the main database. So it's not a fully microservice, but at least we could offload the API. We tried to use application gateway originally, and then found that unbelievably, swearbox, wildcard URI routing was in private beta, and we have never been allowed into that private beta despite trying to apply for it. I've never squeezed my account manager in Azure to get me into that beta. So that means you couldn't wildcard everything on this route go to that box, everything in this route go to that box, which means you now need about 200 rules. The other problem is we had subdomains for certain customers, so it meant all our rules were going to start exploding. The fortunate bit was that we'd already played with Front Door, which can do multiple region routing, and actually that suited better as soon as we realized we needed a resilience story. It's interesting why you need a resilience story. One of our third parties, banking service, sent an email around saying, we apologize for the degradation in some of our back-end services. And the reason they had the problem was the entire region UK South, which supposedly has multiple availability zones, absolutely died completely and utterly for 8 hours. UK South disappeared last November, something like that. And I think they had an air conditioning fire or something, and it just chopped the entire building, including the multiple availability zones. So at that point, I had the management team go, we need to be multi-region resilient because, you know, Dublin could go down. And having had the lucky thing of, as part of the MVP program, visiting one of the Dublin data centers, I had very little expectation that that was going to go down. But we went with Front Door, but then we put Front Door in, and now it's stripping our X-forwarded 4 header to show the IP addresses. What's the client IP address? Because we check people's IP addresses. So now we have to go quite a bit around the houses. We've had to set up security groups with the networking between Front Door and our app services so that we can trust that the IP address given us was genuinely pushed into as a header into the request by Front Door. So it's no good just saying we've got an X-forwarded 4 header, because our nasty little hacker could have put that in their original request. And if that fed through to us, that would be bad news. So, and client certificates. Apparently, Front Door doesn't believe in client certificates and throws them away. So any request coming through Front Door goes and comes with no certificate when it lands on you. The fortunate bit is we only use client certificates for authentication. So we decided that what we will tell is the client, the people who use client application logic and our API as a real client, they will authorize on one of 2 endpoints. If they try one and it's not there, go for the other one. And they know to fail over between those 2 endpoints. Once they have a token, they're completely in the world of the API that Front Door can manage. and the client certificates are not used at that point because we trust that the auth token was only granted to someone who gave the correct client certificate. And that way we can still do multi-region failover without too much effort. And it's not unusual to be able to ask those customers. It's always like a service discovery endpoint. So we even said to them, if you really want, you can come in via an API to request where the auth server is, and then it will tell you how to get to the auth server. You can use the auth server and then come back in via the API afterwards. And obviously that API call that finds out where the auth servers live will not need authorization because that would cock it all up. So there's workarounds on that, but the extra thing we get with front door being able to handle multi-region routing, and we did a test failover, we flicked the switch and we could fail over the entire site in about 4 minutes. That's every service being stopped, restarted, all requests moving over and the database moved over. And that's how long it will take us to go from to effectively do our DR. And we're so confident in how it worked and the way front door works, we're probably going to go to a live system instead of a DR center so that we actually balance our load across both. And then we will have a much better solution in the long run because we won't be paying loads of money for something in Amsterdam that never gets used, because clearly that's madness. And the other thing that's always got to be pointed out, by the way, in regional failover is if you say, I have the capability to fail over from this data center to this other data center in the cloud, and everyone else knows that, and they're going to do that. If you haven't actually got reserved kind of machines already running in the second data center and the first data center goes down, everyone is going to try and move to that second data center. It will not have the capacity to host everyone, right? That's the reality. If they did that, they'd have to have double the amount of stuff that they ever need in every data center, and they don't do that because there's accountants and money and things. So you're better off having half your power in one data center, half your power in another. If a region ever went and you had to go to the other one, you'll be half powered, but that's better than the people who are only 10% powered because they can't scale anything up because there are no resources to scale anymore because everyone is heading to that data center. And that has happened in AWS regularly, where AWS in East Coast has gone down, the oldest center, and it has put an immense pressure on the rest of the network because suddenly everyone is trying to hit everything else. So yeah, so that was our app service and regional failovers. The other things we've added in my time at Free Market, we added Signal R. So this is WebSockets. Only Azure kind of has it branded as Signal R. I suspect AWS has WebSockets, but dealt with quite a different way. But being Microsoft, it was Signal R. We've got Microsoft devs, so they're quite happy to do it. They did a demo in Java so that the guys users who have Java clients can do it, could work with it as well. And the reason we had to do this was we had to go away from the REST model because we were trying to stream live currency trade prices from the market, and we were probably doing at least one a second, if not 2 a second. We were actually getting about 7 a second given to us, and we were trying to trim them down and only do about once every second down to the browser. And that's really hard to do with HTTP and REST and polling and all that. Never mind the fact that it's going to absolutely knacker your back-end infrastructure if everyone's polling every half a second to find out what the latest FX price is, which is what you would have to do given the 200 milliseconds it takes for a complete round trip, or for 300 milliseconds to get a every second update. We even found that we were only streaming the prices initially, and then we found that actually when you said, yes, I'll buy at that rate, about half the time we were too late with REST to be able to execute at that market rate. So we now send the actual call to execute a trade down Signal R as well. So it's bi-directional. It's not just data to the browser. We have API calls coming back up. And the really nice thing about the Signal R was you just switched it on, like genuinely. You just went, right, we'll use Signal R then. In Huddle, one of the first things I've had to do was write up the architecture for Signal R and actually work out the bits and actually put comments. I think I had to comment back to David Fowler that bits didn't work. because it was that new at that point. And to do Signal R, you had to have backplanes if you were going to cluster it. So even when we went to put it in AWS, you had multiple boxes, and then you had to have a Redis backplane to kind of handle the messaging between them and all sorts of things. Instead, you just switch it on in Azure, and we've got 100 connections, and you can get 1 million messages a day pushed through the system. And that's £35 per month, which is the price of a cheapest VM you could possibly buy. So it's just amazingly cheap, this one. So it's a no-brainer because it scales, it does the scaling, it does this network scaling, it does the backplane, and it's £35 a month. If we needed more messages and more stuff, you start paying an extra £35. My view has always been for something that cheap is if you have 1 million messages a day isn't enough, you have a nice problem that means you're earning money that allows you to pay the £35, let's be honest. And if the cost of it is higher than you can get from your customers, you've got a bad business model. So realistically. Equally, Redis, we put in caching for Reddit, a Redis caching, fully managed service. Don't need to worry about clustering, they deal with it. It's got a 3 nines uptime. 3 nines sounds wonderful. It still means about 9 hours a year. It could be down, but then it only costs £30 a month. If I want it to be only 11 minutes, which is 9995 on the higher plans, I can pay £300 a month. That's the point at which they start doing persistent storage as well, whereas we just want caching. And the whole point about a cache is if you didn't have the cache, it wouldn't matter because it should still all work. So it's quite happy that although it can't be geo-replicated, we can just have a different cache in Dublin, different cache in Amsterdam, and they'll just eventually fill up. So it doesn't bother us really. Things like AWS have Elasticache for Redis. They've branded it in some weird way instead of just saying it's Redis. They've probably put some custom code in and then not contributed it back to this. I'm being a bit cynical there. But it's a fully managed Redis cache. And to some extent, you've got more fine-grained control on it than with Azure Redis. And you can fiddle with things quite a bit more. This reminds me of where of a DDD East Anglia. I was in a very hot room that David Whitney was at the front of. He was discussing Azure versus AWS. And he highlighted that there's a kind of different mindset between the platforms. The AWS guys are kind of more low level and closer to a classic data center. It's like the network engineers designed AWS and have made everything configurable and tweakable and manageable. Whereas Azure came along later and went, you know what, that's just reinventing the data center in the cloud, but we want to be kind of the cloud. And the only reason they could do that is because they were late, right? Don't underestimate the fact that they got the advantage because they weren't there early on. Whereas AWS had to convince everyone to move from a data center into the cloud, and they had to mirror the kind of paradigms of the normal data center. So that's one of the bits where when you look at the products, you can see that AWS is more network geeky. And the other thing we're about to adopt is Azure Service Bus. So we are about to go microservices. We've got a 9-10 month plan to break up our monolith and start chunking it into different app services, but each with their own database. But obviously we need messaging between them. The current end service bus pattern that's being used uses the SQL database itself, which clearly is madness. So we are going to move to using Azure Service Bus. We are keeping end service bus, much to the annoyance probably of someone like Ian Cooper, who would recommend we use Brighter. But the reason we're doing that is we only have a small team and we have 10 months to do this. And there is a limit to how many moving pieces you can change. And this is one of the pieces we're not going to change because it will work better. We may need to buy additional units depending on the performance, but we did evaluate this against RabbitMQ. But you've got to evaluate all the costs. So, because by the way, Azure Service Bus is not cheap. It's £500 per month in order to have a messaging system, which seems really high if you're used to using MSMQ and having just lying around on your Windows box or something like that. Or it's in your database, so it's kind of free. But to do RabbitMQ, we'd need 3 Linux virtual machines with a decent amount of CPU and memory. We'd have to research how to install and configure RabbitMQ. We'd have to maintenance of the virtual machines, hardening Linux, patching RabbitMQ. And that doesn't necessarily go multi-region, whereas £500 per month makes Azure Service Bus go across multiple regions. So we just took a pragmatic view that if in the long run Azure Service Bus is far too expensive, that's when we put the RabbitMQ in. And the advantage we have with this is because we're using N Service Bus, we've actually isolated ourselves from the message transport. So N Service Bus could happily use RabbitMQ just as easily as it can use Azure Service Bus. So bizarrely, we've made it easier for ourselves if we need to switch to RabbitMQ in the future. There is a bit of no service stuff that we do as well. So we've got Azure Functions. These are the short-lived type things. So we do have serverlessy type stuff. Yes?
Alan is asking, is that RabbitMQ cluster from the marketplace?
No. Well, the problem is if you got RabbitMQ cluster from the marketplace, I believe that. So this is. I was looking up some data on it today, and some of them are a bit older. But you would need 3 machines to run it on. It would need Linux VMs. And all that the marketplace does is give you a starting point to have it. And you've got to kind of define what. So the marketplace, when I looked at it, I wanted a managed service. And what I didn't get was a managed service in the marketplace. What you got was, here's the initial, this is what it should look like when you first build it. It will configure all the defaults for you. But from that point on, you're really on your own. That's how I felt it was. If someone has a different experience than that, I'd love to know, because that would be interesting. But you still end up, the marketplace is just a way of kind of like almost Docker has a container registry where you can pull things down. If you think of it like that, then you can pull it down, but you've still got to maintain it and configure it and do things. And that was the issue we had. So, and it's a time thing. So as well, on time to market, time to be able to re-architect our system before we run out of money and things like that. That's always going to be a startup's worry. So we use functions to do things like monitor errors, or monitor how many messages were backed up in N Service Bus queues and things like that. So they can be really nice to just kind of regularly go through. Whoops, went the wrong way. And the other thing we use is these weird things called runbooks. So runbooks, if you had your own SQL server, you would have SQL Server agent scheduled jobs, doing things like backups, doing restores, doing tidy ups, all that kind of thing, possibly moving data around for a data warehouse. Instead, we've leveraged runbooks. So PowerShell or Python, and we've gone PowerShell because, .NET. And for some reason, I've never got on with white space being important. It just freaks me out. It was hard enough for me to go from Visual Basic to C#, where case became important. And I could that was a bit of a shocker for me. And they're longer lived than functions. They can run for 3 hours, which sounds like a long time, but there's certain things you do in SQL that take more than 3 hours, which is a bit of a nightmare as well. And there's PowerShell modules for Azure Resources Manager, Azure SQL, and standard .NET libraries and things like that. So one of my little demos, if I get to it, yep. Is so. So here's a runbook. Now I remember what I was going to do. I will go to the next page of my slide because I mentioned something. I think, let me go. Aha! Here's my square box. Right. So now I remember. In runbooks, you are effectively just injected in some random virtual machine somewhere in Azure, and you have no idea what IP address you're going to get. And remember, way back, I talked about a SQL firewall having IP addresses, and runbooks can't be in a virtual network. So unless you go a hybrid worker that's much more expensive, effectively a VM that's dedicated to you. So we had to work out how on earth are we going to call things in SQL from the runbook. And I came up with the maddest scheme in the world, which basically is you try to connect to the database. And when it has an exception, and the exception has the words client with IP address in it, it means that the message actually says something along the lines of firewall check failed, cannot open server, blah, 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 requested by the login, client with IP address 192, blah, 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 is not allowed to access the server. I actually grep the IP address out of the exception message that SQL gave me, and then add that in here to, let's see if I can use the highlighter. No, it refuses to allow me to use the highlighter. Okay. So I add a new SQL Server firewall rule for the life of that runbook. So I find out what my IP address is by nicking this thing out of the message, check the, add that as a firewall rule, do the stuff that I need to do on SQL Server, and then I remove the firewall rule at the end of my runbook. I actually, in them all, check whether that rule already exists, remove it, then do this new firewall and do all that kind of tidy up work, and just to be safe and sure. So only today did I find a 4-year-old Stack Overflow message that said, oh, you don't want to do that. What you want to do is just invoke a web request with this basic parsing. So if we go to the screen, this is a runbook, and I can test it. And if I look at the last test, you can see that the last time I ran this, which was about 4:30, I got .94, 52.164.24.94. Now, when I run this little bit of PowerShell, and this is where you really feel I'm in a virtual machine pool, and look at that, it's queuing it, and now it's running it, so that's good. It gets harder when you're debugging these because it kind of throttles you a bit. So you can see that I now have a new IP address, and this IP address changes. If you ran a runbook and 2 minutes later come back to it, the chances are it's changed its IP address. It's that fast to change the IP address because you're on a random new machine. And in that edit, you obviously wouldn't do the rubbish trying to open the database. But what I wanted to show is that that nice little bit of PowerShell gives you a very clean IP address, whereas this was the messy exception that I had to extract this IP address out previously. So I'm glad I did this talk today because it meant that I found a much neater way of getting an IP address from a runbook. You might have said, couldn't I just go to somewhere that there's websites that just return your IP address? And you can't, because you are not allowed into the open internet from a runbook. It's a very secure sandboxed environment. You are only allowed to talk to internal Azure resources. So my conclusions on this whole experience, we definitely do the trial and adopt pattern. So we kind of go for the ThoughtWorks kind of tech radar. So we brought Redis in on a project and worked out it works. Not only did it work, we worked out how we'd push a kind of JSON HTTP pseudo API down a WebSocket pipe so that anyone who developed with it externally was familiar with the fact that we returned a 200 or a 404 and things like that in the JSON, even though it isn't really a HTTP protocol. And the point about that is, in the longer term, if you need to, you can build out your own version. So you take Azure Service Bus, you use that. If you think RabbitMQ would be better suited and would be worth having, then you can start using RabbitMQ and build that out. You escape the illusion of control, right? Everyone believes that they have, if they had their own VMs, they have complete control. You still don't have control. There's networking connecting between those VMs in a cloud service. At any point that network could go down. You don't really own the load balancers or the routers. You don't even necessarily have control of, oh, I don't need to patch. I'll only patch when I need it. If it's an emergency patch and it's really crucial, you're going to have to push it out anyway. So costs, right. We don't need a tech ops team. We're not really DevOpsy because there's less ops than you might think if you're using platform as a service, because we've outsourced the ops to Microsoft. That's who's doing the ops. That's who's patching. That's who's load balancing it. That's who's monitoring the ultimate hardware CPU and memory levels in those services, not us. And you have to balance those PaaS additional costs against opportunity costs. So can we do something in a month instead of in 3 months or 2 months, and therefore get a customer, and that customer is going to come on board? If we prove that we could do it a different way, we can do it a different way. And the internal support costs of just being up to date. We're a Windows shop. We don't do Linux. We now need a load of people who understood Linux properly to understand how we patch it, how we harden it, how we do everything for Linux. And that would not be a fun thing. And the lock-in myth, like everyone said that an ORM, if we used an ORM, we can just move our app from SQL Server to Oracle and it'd be transparent if you get the right ORM. And no one ever does it, right? No one. And the same that's happened with cloud. There's this whole thing of we can be cloud neutral, but you could work so hard to be cloud neutral, it will cost more than if you just rewrote the bloody system in a different cloud platform. You know, there's an element where if you're on AWS and I used Redshift, I haven't got an option to leave AWS. It's the same as using Azure Service Bus. There are certain things you're going to have to just be ready, go, that ties us to this platform in a way that we're happy with, you know, and that's fine. And that's it. That was my little fluffy cloud talk, which is my journey into Azure and platform as a service.